I'm Anil Kumar sharing with you the ultimate multiple choice question on analyzing first and second derivative. The question here is, which statement is always true for a function f of x with a local maximum at x equals to a? A. Derivative at a is 0. Second, derivative of second derivative at a is less than 0. Third, product of derivative at x1 and x2 is less than 0 if x1 is less than a and x2 is greater than a. That is, a is between x1 and x2. And both derivatives at x1 and x2 exist. D. There exists an interval I containing a such that derivative at a is greater than 0 for all x less than a in I, and the derivative f dash x is less than 0 for all x greater than a in I. Is there exists an interval I containing a such that f of x is less than f of a for all x in I. So these are 5 options for you. Which one of these is always true? You can pause the video, think about it, and then answer the question. Think about different situations. That is going to help you answer this particular question. Here is how I will solve it. We are looking for explanation of maximum at a, right? So let's take 2 examples so that we can derive at the result. If you're thinking about something like this, let us say, so we do have a maximum at a point A, right? This is what we are calling A. And we see that all these conditions given here are correct. First derivative is 0. Second derivative is concave down, and therefore it is less than 0. Product of derivative, that is, if I draw a tangent here and a tangent on the other side, one is positive, the other one is negative. It goes from positive to negative, and therefore we have a maximum. So the product of derivatives in the interval, which is before x, before a and after a, is always less than 0. That's correct. There exists an interval I. Let's say this is your interval I. There exists an interval I containing a such that derivative at a is greater than 0 for all x less than a. So on this side it is positive, right? And on the right side it is less than 0. Clear. D. There exists an interval I containing a such that the value of the function, which is f of a here, is greater than f of x. So all other values are less than f of a, and therefore it is called local maximum, correct? So all seem to be correct. However, the question clearly states which statement is always true for this function for local maxima at x equals to a. So we need to look for another example which should help you answer the question. Now here it is. Think about this example. Now what is the derivative at a? You can clearly see that the derivative of the function at a does not exist. Since the derivative does not exist, a, b, c, d is not relevant. Do you get the idea? Derivative does not exist at a. It exists in interval closer to a, right? It does exist before and after. It is positive changing to negative, but at a it does not exist. And therefore, all these conditions are not true. The only condition which is true is E, and that is always true. For a local maxima, the value of the function at that point is more than the value of nearby interval, right? So the closer interval which we are talking about, around A, the value of the function is highest at A, and therefore option E is the right option, right? So this is a very good question which sometimes is very confusing, and I hope you understand it. Share your comments on this video. I hope that is going to help many students, and I've seen this question many times in SAT, IIT, JEE, and such test papers. Thank you, and all the best.